Welcome, everyone, to this session of Views on the Future, What's Next, sponsored by Women in Drones. I'm your host, Bill Johnson, and with me today is the COO of Sundance Media Group, Jennifer Pidgen. Jennifer, I know that SMG is a consulting group in a broad part of the UAS industry, but you're now focused, and we'll talk about this more later, focused on the construction and surveying industry, or part of the industry there. I also want to point out that you're a member of the initial 2023 cadre of the Hall of Fame in Emerging Aviation Technology. You were just awarded that at CES at the beginning of the month. And interestingly enough, as I looked in your background, you are a USPA wingsuit and speed diving judge. That's pretty impressive. I appreciate that. Must be a good adrenaline rush for you there.
Well, I don't actually participate in the sport. I just judged it, but it's pretty awesome nonetheless.
Yeah, I bet. So welcome to the show, and thanks for being here. Could you give us a little background on yourself and maybe even SMG and where you are right now?
Yeah, absolutely. Thanks, Bill, for having me on this interview episode. I appreciate being part of the conversation. Let's see. Well, I'll back it up just a little bit. I've actually been in the drone and unmanned, now uncrewed industry since about 2012. We were trying to decide whether or not drones were going to be the next big thing for photographers and videographers. We basically brought in the Phantom 1, I guess it would have been January of 2013. Wow. And from that point on, I was completely hooked. So we basically brought in the drones. We had photographers and videographers scrambling all over the place for this new view of aerial cinematography and photos. And I saw the vision. So in 2015, and a number of drones later, I actually bought into Sundance Media Group, which is where I am now. And this company has been training and consulting within the consumer electronic industry for 30 years this year. So we're celebrating our 30th anniversary this year. And then I moved from Toronto, Canada to Las Vegas, where we could fly literally 98% of the time. We have beautiful weather, so it makes it a lot easier to work within the drone technology. And I've also been a very proud and avid member and supporter of Women in Drones since 2016. So I've been working side by side with Sharon Rossmark and Wendy Erickson since the inception of Women in Drones. And I love the organization and how we're bringing this technology to different industries, but also to women as a potential career path. So, and now 2 years ago, we basically dove into the survey, construction, engineering side of things. There is a very large market there that has pretty much been untapped at this point. I would estimate that maybe 3 to 5% of those particular organizations are using drones in any capacity. And for their workflow, it is actually a big time saver for them. So my job is to try to educate and showcase how that technology changes their workflow and brings them more time to be doing other things.
Yeah, so you, in effect, you are not really flying the drones per se, right? I know that you are also you have training, SMG has training events, but you're, like you say, explaining to the industry, the construction industry in particular, how they can be used. And so you keep up with the technology that is useful and the applications of that technology for their mission, I'll call it, their scenario.
Yeah.
Right. Okay.
Yeah, that's exactly it. So from time to time, we do get out and do some really cool and fun shots of what's going on. And of course, we have to know what the workflow looks like. So oftentimes we are kind of the translator between the manufacturers and the people in the field actually using the drone technology. Oftentimes, the drone manufacturers are like, we'll build it, they'll buy it. And that doesn't really work in the real world. It really is a matter of what are the clients looking for? How are they using this technology? Where are the pain points that they're having with the technology? and how do we smooth out all of those pieces? So that's kind of where Sundance Media Group fits, is in that middle translator, I like to call it. So we translate, down to the client how to use the technology, but we also feed it back up to the manufacturers and say, hey, if you tweaked it this way, it'd be a whole lot easier in the field for that workflow.
Yeah, that's great. And that fits perfectly into the discussion that we want to have on the future about what's coming up. So the first question is, where do you see is maybe the biggest impact or the biggest step that will be taken in that construction surveying industry and the technologies that support it from a drone perspective? What do you think is going to happen next? In the next maybe 2 years or so?
Yeah, so right now, LiDAR is really the big hot topic in survey.
And LiDAR is laser, IR?
It is actually light detection and ranging.
Okay.
So yes,
gosh, I knew that it was using photometric and photos to do the ranging.
A little bit different. So let me back it up a little bit. So
Sure.
photogrammetry is actually taking photographs, and we take number of photographs from an aerial point of view, and then we stitch them together in a program by the pixel. So we're actually taking RGB data and using algorithms to stitch it together to create one map or a 3D model. Depends, how far we're going with it. LiDAR, on the other hand, is lasers. So you're correct in that it is lasers, but LiDAR actually stands for light detection and ranging. Okay. And those lasers, those lights, are bouncing around and then being captured. And the data set that we're pulling out of LiDAR is actually much, much smaller because it's only a point. So it's a multitude of points that then get matched up and create the models out of the programs much, much faster. So in comparison, so the switch from photogrammetry, which I think within the drone industry, we've really come to appreciate and understand in a variety of verticals, public safety, inspection, survey construction, even sometimes when it comes to some of the really great, beautiful photographs that are coming out of some of the photo drone pilots, we're now moving into, let's get it precise. How do we get it accurate? And then we have to have another whole layer of discussion. So part of our challenge within the survey industry is that surveyors expect precision. And so for them to start to really believe in the data, we have to show them that this data can be precise. And we do that by geo-rectifying it. So we basically tie it to GPS points.
Right. And those GPS points are very precisely known for particular points on the ground. And as I recall, and I had a little bit of background with LiDAR from my time with Northrop Grumman, but LiDAR and laser in particular is very precise in that ranging, right? Because of the wavelength that you're at, very tiny, you can be very precise in how far it travels in a particular amount of time, right?
You got it. Absolutely. Okay. And some of the differences, and I guess maybe the benefit of LiDAR over photogrammetry, is that we can cover a lot more space in a smaller time frame. So a good example is a great point. 10 acres. So 10 acres with a drone and an RGB camera probably take you between 45 and 75 minutes to capture the data, depending on the drone. And then to process that data, because we're now tying pixels together, and pixels are memory hogs, probably between 5 to 6 hours to process the data so that you have your model. LiDAR, on the other hand, we can do that same 10 acres in about 15 minutes. So 15 minutes instead of an hour. And then to take it into your software program really would only take you maybe an hour to crunch that data, maybe. Wow. And that's on the very conservative side.
That's impressive. That's really, I didn't realize how different it was in the time frame.
Yes.
That's incredible.
Yes. So part of that is because with LiDAR, we can go higher and we can capture more area at the same time, and we have less overlap. So if you've done any work with mapping in general, photogrammetry or LiDAR, photogrammetry, we're between 70 and 80% overlap, where we've got pixels kind of overlapping, and that way the software algorithms can map them and put them together.
Right.
And with LiDAR, it's 30% would be your max. So, maybe 20% is probably comfortable for LiDAR overlap. So it's less overlap, which means we're covering more space at the
Right.
same time as we're flying.
Got it. That makes sense.
Yeah.
Okay, so with that context, it sounds like this is the next step, getting this type of technology to be more broadly implemented. That's cool. But how then, over the next, let's say, 5 to 10 years, do you see this expanding or changing or becoming even better than what it is now?
Well, it would be wonderful for beyond visual line of sight to, come forth, because then we can literally hit a button with a programmed drone to run a mission. Part of a survey construction site is doing progress reports. So you have a program, you're 100% exact on what that flight looks like and what the data capture is, and then we can, capture that data as it's being built, and we can compare to the drawings and make sure that we don't have any issues as it's being built. So that designed as built comparison, and being able to make that automated because you don't have to have someone at the controls, would be brilliant. And I would love to see that happen within the next 3 to 5 years. On the technology side, right now we're working with mechanical LiDARs. And solid state LiDARs is actually a real thing right now. And that's something that currently we can't really use with drones, because it's just not, the distance isn't there. You have to be fairly close with solid state. A solid state LiDAR is on your iPhone, right? Okay. So the most recent iPhone has a solid state LiDAR. Right. But you really can only capture that data within 10 to 15 feet, which just doesn't work for drones. But realistically, having that on a drone that has the distance come to it would be really powerful, because it's a lot cheaper. So I know companies like Pix4D is working on that challenge, if you will. And then the Velodyne Velobit is coming to play. It's a puck. It's very inexpensive, and it's about 100 meters. So we're getting there, but it's still too short for basically drone applications at this point. So from a technology point of view, that's kind of exciting and coming down the pipe.
Okay, that's interesting. I'd like to shift back to the beyond visual line of sight, because you said, boy, it would be great if that happened. From your point of view, from watching the regulations and the infrastructure development that is going to be required, do you think that it would be feasible to be expecting that in 5 to 10 years?
Yes, I think so. With the right safety protocols and having a program in place, I don't see why we wouldn't be able to get there, in terms of, here's our project site, if you will. Here's the safety parameters that we have to offer. No different than requiring a waiver for night flight at one point, or, flight over people. This is just another step in the conversation. And I think as it starts to become more and more of a part of the workflow, it will be part of the process of, okay, if you've got all your ducks in a row, we'll give you the waiver for it. And maybe it's just that area, right? Sure. So go ahead, let your mission fly.
Well, boy, this has been very interesting for me. I know it's quick and we could last forever, but I'm going to draw it to a close, understanding that there's really exciting technologies, particularly in LiDAR, like you said, and there's real progress being made in the regulation and how far you can use that in beyond visual line of sight. Really cool. So thanks for being here, Jennifer. I certainly appreciate it.
It's my pleasure. Thanks so much for having me, Bill. Appreciate it.
Okay, everyone. That's it for this session of Views on the Future. What's next?